Stars are giant balls of gas, mostly hydrogen and helium. Imagine a recipe that calls for a whole lot of hydrogen and a sprinkle of helium. That's what stars are made of. These gases are spread out in space, but gravity pulls them together. Gravity is like a cosmic magnet drawing everything closer. As more and more gas clumps together, the gravity gets stronger. This pulls even more gas towards the center, making the clump bigger and bigger. Over a very long time, this giant ball of gas becomes incredibly heavy. All that weight pushes down on the center, creating immense pressure. Think of squeezing a balloon really hard. The pressure inside increases. Deep inside the core of a star, the pressure is unimaginable. It's like having millions of elephants standing on a dime. This intense pressure squeezes the hydrogen atoms together, forcing them to get very, very close. Remember those hydrogen atoms, the main ingredient in our cosmic recipe? They're about to undergo an incredible transformation. The intense pressure and heat in the core create the perfect conditions for something amazing to happen. This extreme environment is like a cosmic pressure cooker. Just like heat and pressure can cook food and change its properties, the conditions in the star's core alter the very nature of the atoms themselves. Under these extreme conditions, the hydrogen atoms are no longer content to exist on their own. They are forced to fuse or combine with each other. This process is called nuclear fusion. Imagine two drops of water merging to become one larger drop. That's similar to what happens during fusion, but on a much smaller scale, with atoms. This isn't just any ordinary chemical reaction, it's a nuclear reaction, and it releases an enormous amount of energy. It's like millions of hydrogen bombs exploding every second, but in a controlled way that keeps the star stable. This energy is what makes the star shine. Think of it like this. The star's core is like a giant power plant, constantly generating energy through nuclear fusion. The cosmic dance from hydrogen to helium. During nuclear fusion, 4 hydrogen atoms combine to form one helium atom. It's like a cosmic dance where 4 partners come together to form a new entity. But here's the catch. The helium atom has slightly less mass than the 4 hydrogen atoms combined. So where did that tiny bit of missing mass go? It's converted into energy according to Einstein's famous equation E equals mc squared. This tells us that mass and energy are interchangeable, and a small amount of mass can release a tremendous amount of energy. This energy is released in the form of light and heat, and it's what makes stars incredibly hot and bright. It's also what allows stars to keep shining for billions of years. Shining bright energy's journey from core to cosmos. The energy produced in the core doesn't just stay there, it has to escape somehow. It travels outward through the star's layers, a journey that can take thousands of years. It's like a game of cosmic pinball, with the energy bouncing around until it finally reaches the surface. Once the energy reaches the star's surface, it radiates out into space as light and heat. This is the starlight we see here on Earth. It's amazing to think that the light from our sun began its journey from the core millions of miles away. This light travels incredibly fast, at the speed of light, of course. It takes about 8 minutes for light from the sun to reach Earth. But light from more distant stars has been traveling for thousands or even millions of years. Twinkle, twinkle. Why stars? Appear to blink. Have you ever noticed how stars seem to twinkle in the night sky? This twinkling is actually caused by Earth's atmosphere. As starlight passes through the atmosphere, it gets bent and scattered by the air molecules. This bending and scattering makes the light appear to flicker, giving the stars their characteristic twinkle. It's like looking at a penny at the bottom of a swimming pool. The water makes the penny seem to shimmer and move around. So the next time you look up at the stars, remember that they are giant, shining balls of gas, powered by nuclear fusion. And that twinkle you see, that's just Earth's atmosphere putting on a light show.